Hello and welcome to this video. In this video, we will see Lambda. I have promised in my previous video to show a video on map, filter and reduce. But before that, I would like to show you another video on Lambda functions in Python. Lambda calculus was proposed by Alonzo Church and Turing. Later, it got major adoption in Lisp language. This lambda has come from the similar semantics. In Python, lambda is an expression, not a statement, and the lambda's body is a single expression, not a block of statements. In general, let's say you have a function which is composed of only a return statement, then you can translate that to a lambda. For example, we have a function def add x comma y which returns sum of x and y. Then we can call it like that, which will print 5 if we pass 2 and 3. But the same def can be written like this: f is equal to lambda x comma y x plus y. In this case, lambda is an anonymous function which takes two arguments x and y and returns the sum of x plus y. This anonymous function is captured as function f, and then you can call f by passing 2 3. This will also print 5. Default arguments which we have seen for functions also works on lambdas. So in this case, this lambda takes three arguments, three default arguments: a is equal to this, b is equal to is, and c is equal to world, and then concatenates all three strings and returns 2x. In this case, I have called x with it, so it will output it is world. Now, if you see this, what happens about the scope of lambda is lambda can capture any variable supplied to it by enclosing function. For example, here teachers is a function, title is sir, and action is an anonymous function which is a lambda which takes an argument and concatenates that with title and a space and returns action. So as we have seen in closures, it will capture the variable and save it. So if we capture the closure edge act and we pass act shiv, then it will print sir shiv, as you will see here for the third print statement. Lambda can also be used to jump tables. For example, I have a list which is composed of three lambdas. One is x to the power 2, then x to the power 3, and third x to the power 4. In this case, you can iterate over each element in list supplied with an argument which will be printed. So it will print 2 to the power 2, 2 to the power 3, and 2 to the power 4. You can also take any particular lambda argument supplied in this list and invoke that with an argument. So L03, this will print 9. You can do this with functions also, and your functions can be large also, but those have to be named functions. Those cannot be anonymous function. So you might have some name clash or something like that, but it is also doable with function. So let's see the output of this program. So first is 5 for add 2 comma 3. Then for the lambda, we have got 5. Then it is world. Then we have Sarshiv and 4, 8, 16, 9, 4, 8, 16 for function f1, f2, f3. And then we have 9 for the last invocation of named parameter in the list. So how you should use lambda is, sorry for the background horn here. Some guy has gone crazy. It's midnight and I'm recording this video. So how you should use lambda is that when you have a function which has got a single expression, much like our nested closure for a class which has a single method, if your function has a single expression, then you should replace that with a lambda rather than having a full-blown function for a single statement. So that with that, I'll conclude this video on lambda. In our next video, we will see how we use map, filter, and reduce, and we'll see lambda in action there also. If you have found this video informative, please hit the like button and subscribe to the channel, as I'll be recording more and more videos. So if there is an interesting topic for which you want a video, please let me know and we'll try to make videos on that. Thanks for watching the video. Happy programming.